Hey everyone, welcome to night 3 of Lambda School's Introduction to Web Development. My name is Deandra Ryan Moss and I am your instructor. I will be teaching you tonight live from Bisbee, Arizona, as usual. And I'm muted again, that's super. Okay, am I unmuted now? Can you guys hear me? Okay, cool. All right. Well, let me start over again. I need to figure out what I'm doing to cause this auto mute thing. Okay, so welcome to night 3 of Lambda School's Introduction to Web Development. So tonight we are going to be covering JavaScript. So far we've covered a few other languages that are pretty key to front-end web development, HTML and CSS. And now that we have those in place, we're switching our focus over to JavaScript. So starting tonight and from here on out, that is what we are going to be doing. So thank you guys so much for joining me tonight. I'm going to talk a little bit about Lambda School and then we will jump into the topic. So we haven't really talked in detail yet about what the Lambda School curriculum covers. And I think that now that you guys have some exposure to some of the languages in this intro course, will be better suited to discuss what's going to be covered in the main curriculum. So the main curriculum is all about web development. So you'll see, what you'll see is a deep dive into everything we cover in this intro class, as well as some totally new topics. So of course, we will be going much deeper into the 3 languages that you've already seen. Well, you've only seen a tiny bit of JavaScript, but you get what I mean. So we'll be doing a lot more with CSS and HTML, as well as looking into some tools that can help with those languages, things like CSS preprocessors and CSS frameworks. And then beyond that, we'll go quite a bit deeper into JavaScript. So over the next 6 nights, we're going to be laying the foundations of JavaScript. But unfortunately, we won't really get into how JavaScript relates to web development in too much detail. And that's all the stuff that's going to be covered in the main curriculum. So really seeing how JavaScript ties into web development. That means front-end web development. So we'll be exploring a really useful front-end framework called React. We'll also be looking at back-end. So as I mentioned on night 1, back-end web development is all about handling data, and it's all the logic that happens behind the scenes and out of sight when you're building websites and web apps. While we don't really talk about back-end development in this course, that will be covered in detail in the main curriculum. So we'll be processing data and also exploring some database languages like SQL and how we can use that to load and retrieve data from databases. So you'll have the entire stack under your belt. That means that you can build a web app or web page from start to finish. All the pieces you will be able to build. But beyond web development, we want to make sure you guys are rounded out as developers. So we also spend some time on C, which is an object-oriented language. I'll talk more about those tonight. And we'll also cover Python and some data processing with that. So you'll come away not only with a ton of super practical skills for building web content, you'll also come away with some other skills on the side, which are good for understanding things like algorithms and also just for doing other tasks. Like, for example, Python is like the language for data science and AI. So it's a good one to have some exposure to. Well, that's a little bit more detail about what we'll be covering in the Lambda School main curriculum. If any of you guys are curious to learn more about that or get started on your application process to the main curriculum, please reach out to Karen, Zachary, and Slack. As a little reminder, Lambda School is a 6-month entirely online, full-time, immersive program. And it is 0 upfront. So if you guys want to join us, you do not have to pay your tuition until you get hired after the fact. So there's a little bit about Lambda School. Each night I'll be telling you a little more so that you'll come away from this intro course with a really detailed understanding of what Lambda School looks like. So now I'm going to switch focus over to our big topic for tonight, which is JavaScript. So JavaScript, as I've mentioned, is part of the trifecta of front-end languages. We've seen 2 markup languages already, which are HTML and CSS. Those are good for rendering content, but JavaScript is a bit more advanced because it's a programming language. So there's a little more of a learning curve, but there's a lot more that we can do once we have it under our belts. So I'm curious how well you guys were paying attention on the first night when I talked about JavaScript. So I'd like you guys to jump in and tell me a little bit about what JavaScript is used for in front end and even back end web development. I remember someone last night said that JavaScript is the magic, which is a great answer, but I'm curious to hear some other thoughts. Okay, I see functionality, make web pages interactive, makes things happen, connecting to databases. When people click buttons or submit data, you guys are paying attention. How good. So that is all correct. And you pretty much covered all of it. So it's anything from basic interactivities, so things like colors changing on hovers or something, a modal popping up, basic things like that, to some really complex stuff like data processing that happens behind the scenes. So yeah, that's all great content. Pretty much anything that's interactive is going to be JavaScript. So I'm going to go ahead and share my screen. And I've showed you guys this kind of code base example now the last 2 nights. So I'm going to show it to you one more time so we can talk a little bit more about JavaScript and how it relates to web development, give you some visual examples of what we just talked about. And then we'll hop and REPL it and do some coding. So let me share my screen so we can get started on that. 1 second. All right. There you go. So I've showed you this web page the last 3 nights, and it's just a little example I put together to show you guys how JavaScript, HTML, and CSS all fit together. So with just CSS and HTML, we could totally render this page and have it look exactly the way it looks. As we know, HTML renders all the content and CSS styles it. But there's one thing on here that needs JavaScript, and that's this button. Without JavaScript, this button would do nothing. But as it stands, it makes all the hidden spans appear on the screen. So let's refresh the page and show you that one more time. Ta-da! Hidden words just appeared. So that is one of the more basic things we can do with JavaScript. As just mentioned, there can be some pretty complex data-related stuff going on with JavaScript, but a really good starting point for JavaScript is just making some basic things change. So let's hop over here to our code base and we'll talk about how these 3 languages relate for just a minute. So we have, of course, our friend HTML, should be looking familiar. We can see all those hidden words are marked in spans. When we go over to our CSS, we can see all of the styling, including, and this is a property that I did not teach you last night, but there's a property called visibility, and we can see that for spans, that is set to hidden. So that gives us some idea of why when we first open the site, it looks the way it does. So one thing you can think about with JavaScript, or once you bring JavaScript into the puzzle, is that HTML and CSS are starting points. So when you have a static web page, which is to say a web page without JavaScript, then they are your starting and your ending point. The web page is static. It's still, it will look the same no matter what. But when you have a dynamic web page, which is to say an interactive web page, one that does have JavaScript, the code inside of these 2 files is only going to be your starting point. And that's because JavaScript has the power to actually change things in real time. And so that means that you can completely change the HTML or CSS. You can add HTML elements. You could remove them. You could change the text. As far as CSS goes, you could change colors, visibility, etc. So now we have to kind of switch to thinking about HTML and CSS as only being our starting points. So let's break down what happens in this JavaScript file. Now, this JavaScript file syntactically looks different. And I mentioned this last night with CSS, which is that you can already tell when you have a new language in the picture just by looking at it, because we can see that all of a sudden it just doesn't look like the other languages we've seen. There's some highlighted keywords, there's equal signs. We've kind of used equal signs with attributes, but mostly not. We have just tons of stuff that does not look familiar. And while while, this is a little more complex than what we'll be covering in tonight's lecture, by the end of next week, this stuff will look a lot more manageable. And unfortunately, we won't be able to get to the point where we're actually writing code like this quite yet in this intro course, but this is the kind of thing that you will be able to write in your sleep once you go through Lambda School's main curriculum. But you're still perfectly capable of understanding what it does, even if you don't understand all the nitty-gritty details. So let's talk about that. We start out on line 1 by finding our button. We search through the HTML and find the button, and we save it. Then we do something that's called adding an event listener. That's basically saying, hey, listen for an event. Keep an eye out for the user to do something in particular, in this case, a click. So right here, we're saying, all right, we have this button. I want you to pay attention. And if the user ever clicks it, then execute some more code. That code that they should execute on a click is down here. This line 3, says find all of the spans. Find every single span on the page, and then go through each of them and change the CSS and make the CSS visibility set to visible. So once again, don't expect you to understand the details of what's going on syntactically, but we can all kind of conceptualize that. So that's what JavaScript is doing. It's finding things and sometimes setting listeners, and then on events, it changes the CSS or the HTML. So, and I just saw a question pop up that I think is pretty interesting, so I'm going to answer it right now, which is, does JavaScript change the actual CSS? So I'm not sure what you mean by actual CSS, but it will not change what is in this file. So this file will never change. This file can be, once again, thought of as the starting point. But if we were to inspect, the actual CSS, as I would understand it, is the CSS in real time. So if we were to now inspect this word, down here, we can see that the CSS has been changed. Visibility is now set to visible. So kind of 2 ways to answer that is that, yes, it changes the actual CSS, but contrary to what you might have thought, this isn't the actual CSS. This is just the starting point. The actual CSS would have to be, the actual CSS is what's displayed in the browser in real time. So if we refresh it, we can now see the visibility changes to hidden, and we can even see that change in real time. We see that this old style is crossed out and the new style has appeared. Okay, cool. That was a really great question. I might show that in future lectures now, so thank you for asking that. All right. So that gives you a little, taste of what, excuse me, that gives you a little taste of what we can do with JavaScript. So as we talked about the first night and last night, whenever you learn a new language, there's a couple questions, or whenever you're trying to accomplish a task using a language, there's a couple questions that you need to ask. One question is, what are we trying to accomplish? Is this language right for it? So if what we're trying to accomplish is to make a dynamic website or make a website that connects to a database and allows for posts or users or anything like that, then yes, JavaScript is the language to do that. The next question would be, how do we write JavaScript? As we know, that's not a simple question. There's keywords, syntax, all sorts of cool stuff, and that's entirely what we're going to be covering over the next 6 nights. And then the final question is, how do we run the code? And I keep bringing this up because I think it's an easy question to neglect, but it's important to being a sophisticated developer. So how do we run JavaScript code? Well, there are a few different ways to do it. The first way is going to be via the browser. So JavaScript was designed to be read by the browser because it is the web development language. If we want to, we could always run it locally using something called Node. I just wanted to mention Node briefly, but we are not really going to be covering it until the main curriculum. So Node is pretty critical to back-end development, but you can think of it for now as a tool that you might use to run JavaScript on your local machine, and you might do that using the command line. Not something we're going to worry about in this intro course, but maybe something you might look into if you're curious. So the other way that you might run JavaScript is in a sandbox environment, and we will be using one called Replit. Before I jump in Replit, I do want to talk a little bit about running JavaScript through the browser. So remember with CSS last night that you wouldn't just open a CSS page on its own in the browser. CSS is dependent. It doesn't really make sense to have CSS unless you have an HTML page. The same goes if you have JavaScript that's written for web development. The JavaScript on its own, while JavaScript can stand alone in other contexts, if you're trying to, set up something like we have here that affects things like the web page, then it needs to have a web page attached to it. So just like CSS, JavaScript is going to be linked into the HTML page. So I showed you that this line 5 here links in our style sheet, our CSS page, and line 6 links in our JavaScript page. So once again, that's not something you'll need to know how to do for this class, but it is something that's good to keep in the back of your mind, is that the JavaScript won't just magically run. If we got rid of this line of code, if we got rid of that line of code and refresh this, the JavaScript is broken. That file is still there, but it's not connected to anything. So let me put that back. Okay. So we will not be having to worry about that because we will just be working with JavaScript on its own in Replit. And if you guys wanted to play around with some JavaScript web development, CodePen has a little JavaScript tab that is auto-linked as well. So that's an option too for people who want to explore things in a little more detail outside of class. All right, so enough of this code base. We're gonna put it to rest and hop on into Replit. So you guys should have all created Replit accounts. Otherwise, you will have a hard time having access to the homework. Hopefully you did that. If you didn't, I would do that immediately after class. And Replit, like CodePen, is a sandbox environment. Though it is a sandbox environment designed for programming languages. So it's a much better environment to just run JavaScript on its own. So that's why we're switching over to Replit for the rest of the class. So let me show you a little bit how Replit works. You might write out, this is strange. I don't know I think they updated Replit's interface and now I'm confused. Okay, sorry. I'm like, where is my run code button? It's up here. It used to be down there. Okay, so we might write out a little bit of math inside of here. And I will talk about what is going on in this code in just a minute. But if we wanted to create some variables with numbers in them and then add them together, we could do that in Replit. So over here, we'll write all of our code out, and then we press this run button. And what's really cool about Replit is that the last line of code, the resolution will appear in green over here. So what do I mean by that? Well, this is the first lesson of how to think about programming languages. Every single line of code in a programming language will run, and something might happen behind the scenes in memory, perhaps, and then it will spit back out something to you, the user. So each line of code runs and then has what's called a resolution, and the resolution is what value is popped back out. So some lines of code won't resolve to anything, but others will. For example, line 3, when you add up two numbers, will resolve to the result of that. So the important takeaways right now are that every line of code resolves to it will spit something back out that something might be nothing. We'll get into what I mean by that later. Every line of code resolves to something. And the other takeaway is that the final line of code, whatever the last line of code you write, will appear in green over here. And so that is Replit specific. I want to drive that point home. That is just a feature of Replit. It's really nice. It helps you see what is going on a little clearer. As a reminder, sandbox environments are really great for smaller chunks of code, for debugging, for trying out little things, and they're great learning tools. So while Replit isn't something you would use to write out some complex program. It is great for something like this class. And one of the reasons it's great is because there's a big button that you can press to run your code, which is convenient. Another reason is because it will show you this last line, whatever that resolves to. All right, so that's a little bit about replets. I'll be talking a lot more about how to use it, and especially about this idea of code resolution as we move forward. But let's go ahead and introduce you guys to some data types. So one of the important things that you do in programming languages like JavaScript, actually, sorry, let me pause for a second. There's one more thing I wanted to talk to you about before we got started with that, which is the idea of a programming language. So I've thrown out that term a little bit, and I want to try and help you guys understand what that means before we dive in. So a programming language could be something like JavaScript, Python, C, C#, Java, etc. And this is a good time to mention that Java and JavaScript are not the same language. They are not related. They are both programming languages, so there is some overlap, but Java and JavaScript is no more related than Java and Python or JavaScript and C. It just so happens that they have similar names, and now it will be confusing to everyone for the rest of eternity. So now that I've taken care of that, let's talk about programming languages. So they're quite a bit more advanced than markup languages. There is more of a learning curve, but there's also almost an infinite possibility of what can be done with them. So while JavaScript is designed for web content, you can do basically whatever you want in it. You could create, it maybe wouldn't be the ideal language, but you could create an AI, like an AI game simulation in it. You could create a way of keeping track of your to-do lists. You could do all sorts of crazy stuff with JavaScript. But you have to get a few basic things in place. And all programming languages have some common features like different data types, loops, if-else statements, things that you'll all be introduced to by the end of next week. So there's my little spiel about JavaScript. It is not an object-oriented language. That might be a term you've heard before. If you're curious to learn more about object-oriented languages, you can look that up. But honestly, it's probably not that relevant at this stage. Okay, so that is my little spiel about programming languages. Let's talk about data types. So a very important thing that is done in programming languages is you create objects and you store them in memory. So there are things you create and then you save them so you can use them later. So for example, when I just created that, let me put that code back. I created a couple numbers because I stored them in X and Y because I wanted to use them later. And we'll talk all about how we create these variables and store things. But first, I want to introduce you to the types of things you might create. So we're going to talk about something called primitive types today. So there are lots of types of things we can create in JavaScript. But the primitive types are the most basic ones. So I'll introduce you to them today. So the first one, which you already got a little view of, is a number. How do you create a number? You just type out a number, and then you follow it with a semicolon. Almost everything in JavaScript will be followed with a semicolon. A little word on semicolons: if you leave them out, things usually won't break, but occasionally they will. So try and remember to use your semicolons. I can be lazy about them too, but just try and remember to use your semicolons because you'll get a kick in the stomach down the road if you get in the habit of leaving them off. Okay, so we have created a number. It's super simple to create a number. You just type one out. It could be a decimal. It could be a negative number. All you do is type out a number. So let's talk about this idea of code resolution. So this line of code here, line 2, what we did is we created a number and did nothing with it. So nothing happened in memory there. We just created a number and it blew away with the wind. So this line of code will resolve to that number we've created. And you can confirm that by seeing that in Replit, it appears in green. But this is a very uninteresting line of code because though we've created a number, we've done nothing with it. So keep that in mind. I'll keep harping on that point. So primitive types, the first one is a number. The next one is a string. Also a little note, this up here is a comment. So 2 slashes mean we've commented it out. So I can put little notes to you guys up here, and these will not be read. If I left the comment out, we would get an error because this is not JavaScript. This is just text. So if you want to leave little notes in your code, that's actually encouraged. I personally am a fan of leaving haikus in comments, though my boss at my old job wasn't always fond of that. So maybe take the haiku approach, or maybe just leave more useful comments in your code. Yes, so anyways, comments. You'll see me putting little comments in throughout these lectures. Okay, so the next thing is a string. So a string is, it can be a single letter, it could be a sentence, it could be nonsense, it could be some random characters, it could even be a number. So I know this last example is kind of confusing. I'll get to it in a second. So the point is that these all represent chunks of text, whether they're actual sentences or nonsense or even numbers. So the difference between this last one and the number type is, well, from a visual standpoint, it's in quotes. And in fact, the way to create a string is using quotes. You can use single quotes or double quotes, but don't mix and match. I'll put this one in single quotes too. Okay. So you can always tell the difference between a string and anything else because a string will always be in quotes. So conceptually, the difference between a string containing numbers is this is more like the text string of a number. So this doesn't have mathematical properties. Think about it as, I'm trying to think of a good example. I don't know. For now, just say that if it's in quotes, it's a string. If it's not in quotes and it's a number, then it's a number. And we'll talk a little bit more in just a minute about why it's important to differentiate them. So strings are super useful if you ever want to store a name, an address, quote, a block of text, anything like that, user input, a bio. There's tons of use cases for strings. Strings are super common and super useful. And once again, oh my gosh, I've left out, just after I lectured you guys on semicolons, I just left out a bunch of semicolons. I apologize. So strings are created using quotes. And as a reminder, the kind of same thing is happening with each of these lines of code. We're creating these strings, but we're not doing anything with them. We're not saving them. They're being created and then they're going away. So not very useful lines of code here. So right now we have 6 lines of code, and this one creates a number and then the number disappears. This one creates a string, then the string disappears. Creates one, disappears, etc. And then this last line also creates a string that disappears, but because of replet's built-in functionality, it will appear over here in green. So whenever we've created a JavaScript object just on its own like this, it will resolve to that object, but nothing happens with it. So this is a good way to introduce you to the data types, but that's about it. So, all right. We have our, actually, let me put the comments on the side. So we have a number, we have a string, and then the next one I want to show you is called a Boolean. So Booleans are kind of weird if you've never been introduced to formal logic before. Booleans, there's literally 2 types of Booleans, or 2 Booleans you can create, true or false. So that's a Boolean. This is also a Boolean. That's literally it. So there are infinite number of numbers you could create. There are infinite strings you could create. There are only 2 possible Booleans, true and false. And Booleans are super important because they are a little glimpse into what's really going on with every bit of code. So you guys probably know about binary, 1s and 0s. Don't worry, we won't be dealing with 1s and 0s in this class. But at the core of every computer is just electric circuits. So each circuit is either on or off. That's a Boolean value, true or false, on or off. And as a little glimpse into what's going on behind the scenes with every language, we have Booleans, which have two values, true or false. So we know that we create a number by typing out a number. We create a string by typing something out in quotes. And we create a Boolean by typing either the keyword true or the keyword false. And keywords are going to be highlighted in blue. Remember, keywords are specific words that are built into the language to trigger different things. This keyword says, I would like to create the Boolean true. This keyword says, I would like to create the Boolean false. And another reminder is that if you put true in quotes, not a Boolean, a string. True outside of quotes, Boolean. True in quotes, string. So there are Booleans for you. Now let me show you the two last things I'm going to introduce you to, which are kind of weird. Undefined and null. So these are their own data types. So there's literally only one undefined value, undefined, and one null value, null. And the way you create an undefined value is with the keyword undefined. The way you create a null value is with the keyword null. So don't overthink those. You just type out undefined and you get an undefined value. You type out null. So these represent missing data. And we'll see as we go along in this course, different places these might crop up. But it turns out that these are actually really important for keeping track of when something is missing. And we'll see a great example of how undefined might appear in just a minute. As to the difference between the two, I wouldn't worry about it too much, but the short answer is that most often undefined is the computer's way of telling you that something's missing, whereas null is usually what you as a developer would use to signal to other people that something's missing. Once again, don't get hung up on the difference between the two. Just know that they both exist and they are different. They are their own data types, in fact. Okay, so we've written a bunch of useless code here, right? Because we just create something and then nothing happens with it. Let's create our first variable. So this is the kind of first thing you might do with one of these values is save it in memory. And we do that by declaring a variable. So I'm going to start by declaring a number. And I already did this actually at the beginning. Actually, we'll call this age. Okay. So let's say that I wanted to keep track of a user's age. Well, I would probably get the value from some sort of input on my app or web page, but then I would have to save it somewhere so that I have that. And presumably what would happen in a real code or in a real website is that you would start by saving it locally in memory, and then some fancy code would trigger and save it in a database somewhere. So this isn't the same as saving something in a database. It will go away when the code is done, but it will at least, as long as this code is executing, keep track of this value. So let's break down what happens here. Well, here's another keyword for you. It's called const. It stands for constant, and it is what we do, or is what we use when we want to create a constant variable. That just means that we can never change the value. I'll talk more about that in a minute. So we start with our keyword const, then we name our variable. So this is something that we come up with as the developer. We want to name it something useful, and usually it's going to be either lowercase or something called camel case, which is where the first letter is lowercase and everything that follows is uppercase, or the first letter of everything that follows is uppercase. And it looks like a camel because it has the little, don't worry about it. That's camel case. So you want to name your variable something that's short but still meaningful. So age is a great variable name because it's short and it's clear what it refers to. So this is the part where we declare the variable. We're saying, hey, we're going to store something in memory, and we want to use this word to look it back up. So think of this word as a label. This is like, you know, if you have a collection of books on your bookshelf, this is the label that's written on the spine so that you can easily retrieve a book when you need it. Then we have a single equal sign. So the single equal sign in JavaScript is used for assigning variables. So we will always and only see the single equal sign when we are assigning values to variables. So then on our left side, right side, Then on our right side, we create the value. So this line of code creates a number, as we saw, this chunk of code. But whereas on its own, it wasn't very interesting, as part of this whole statement, it works a lot better because now we're saying, hey, I want to create this, but instead of it blowing away in the wind, we actually store it in memory and use age to look it up. So this is being saved somewhere in memory, and we use this word age to look it up. So I mentioned code resolution. What does this line of code resolve to? This line of code, you might think that it resolves to the value of 66, but it actually doesn't. It resolves to undefined. Remember I said we would see an example of undefined? This is called a variable declaration statement. They don't resolve to anything. So don't mix up code resolution to the code being meaningful, because this is a meaningful line of code. It actually affects what's happening in memory, but it doesn't spit anything back out. So you'll get more of a hang of what this code resolution thing means as we go along. But keep in mind that code resolution doesn't mean that nothing happened. Just because this resolves to undefined doesn't mean it was a useless line of code. It's also good to know that because sometimes people panic when they write this line and they see undefined appear in green. So how do we confirm this worked? Let's look up our variable. So if we just type out our variable name, we can look up the value. So now age actually resolves to 66. That means that we could use that variable name anywhere we might want to use 66. So we could do, if we wanted to create another variable, I'll call this age 2. This is like, these two lines are basically the same because this resolves to 66. So the value of 66 will be stored in here. Don't mix up age with the string age, totally different things. This is not a string. This is a variable name. It's a way of looking up another value. So if we do this, we can now see that age 2 also contains 66. And then if we say added them together, this is exactly the same as if we were adding up 66 plus 66, because that's what's stored in both of those. So ta-da. So there's a little bit more about code resolution. So now let's talk about different ways to declare variables. So const is one of 3 keywords we can use. And I'm going to really focus on 2 of them in this class, but I'll mention the third. So I mentioned that the age was constant. So by default, we want our variables to be constant. Let me explain why. Let's say that you later on had a different user who is a different name and you wanted to, a different user who is a different age, and you wanted to store their age in the same variable. This is bad practice. If age referred to one user's age at some point, it probably shouldn't refer to a different user's. There are going to be some exceptions for this, but as a rule, if this refers to one thing, it shouldn't refer to another. An even worse way you might use this is, let's say that you now had age refer to the age of their house. Let's say their house was 23 years old if you were doing some sort of real estate app. That's terrible practice. If age was a person age at one point, it shouldn't be the age of a house later on. So it's tempting to write code like this, but it's bad practice because you might try and use age later thinking it's one thing when in fact it's something else. So that's why by default you want to use constant, because what happens when you try to reassign something is you get a syntax error, assignment to a constant variable. So once you have set a value to this variable name, that is the only thing that variable name can be used for from here on out. And once again, that's a good thing. That is a good thing. You want to do that. Use const unless you have a good reason not to. And another little note here is that you wouldn't actually need a new variable declaration. So the first time you create a variable name, you have to use a keyword, but every other time it can just stand alone. So let's talk about an exception to this constant rule. Let's say that you had an app that you were keeping track of your user over time. So you know that right now your user is 66, but sometime in the next year they will become 67, and you want to be able to update that. That's good code use because it's consistent. Age is still referring to the age of the same user. It's just that the user's age has changed. So if we tried to update this code, we'd get an error. And that's not good because that's a totally valid use case. So there is a different keyword called let. Let is used when you want a variable that's not constant. So now I am allowed to reassign my variable. And notice that when you reassign a variable, it does resolve to the value that you put into it. So just a little side note, when you declare a variable, it doesn't resolve to anything, but when you reassignment, it resolves to the value. And of course, if you just look up the variable, you'll also be able to see that. So let and const are the two variable keywords I want you using. Use const by default and use let if you know you have a good reason to reassign the value. There's also a keyword called var. I want you to stay away from it. Var used to be the only keyword, but with an update to JavaScript called ES6 that was released, I think 3 years ago, they released let and const. You will write better code if you stick with let and const. If you see code with var, don't be intimidated. It works very similar to let, but I don't want you writing with var. So var exists, but stick with const and let. It will make you a more sophisticated programmer. So that was an extremely long-winded explanation of declaring variables. One more thing just to mention briefly is that you can, of course, assign things that aren't numbers. The examples I showed you were all numbers, but any of these data types are going to be valid. So if you wanted to create a string, you could. If you wanted to create a Boolean, if you want to set something equal to null or undefined, you could. Generally, you would use null if you want to signify that the data is missing. And you can actually, using let, define a variable and not assign any value into it if you want to declare it later. That will be set equal to, I thought it was going to be undefined, but apparently it is the empty string. My bad. So anyways, that is variable declaration. We'll be using it every single day for the rest of our lives. Maybe not every single day for the rest of our lives, but every time you write code, you will be declaring variables. It is critical, which is why I spent so much time talking about it. All right, we do have a lot of other stuff to cover tonight though. So it might be, I will say tonight's a little bit of a longer class. So sit tight, bear with me. All these fundamentals will start to be a lot more fun once we put them into interesting practice throughout the rest of the class. But tonight is kind of about just spewing out all the basic stuff so you're ready to go. All right, so the next thing I want to talk about is the difference between different types. So remember I said that a number is not the same as a string number? Well, that's because there are different things we can do with different variables or different types of data. So I've already showed you that we can do some basic math with numbers. And remember that x is interchangeable for the number 7. X is points at the number 7. So anytime we would want to use 7, we could use x. So we can do basic math. We can divide, we can multiply. So one reason we need to be clear about what we're working with is check this out. What if I instead did y plus 3? Well, it turns out that the plus operator works different depending on what you're working with. If you're working with a number, it will mathematically add it. If you're working with a string, it will concatenate, it will squish whatever you're working with into one thing. So string 7 plus 3 actually is 73, whereas number 7 plus 3 is 10. Just a little example of why you have to know what you're working with. And here's another little insight into some of JavaScript's weirdness, which is that it actually kind of magically transformed this number 3 into a string 3. So you'll see more of weird stuff like that as we go along. Some other cool stuff you can do with numbers is you can compare. So we could do some comparison operators. Notice that this bit of code actually resolves to a Boolean. When we compare two numbers, or two strings even, the resolution will be a Boolean value. And we could always store that in a new variable. So this will actually resolve to a Boolean, which is then stored in result. So that's this really important thing we have to get used to, is this idea that this is interchangeable for whatever it resolves to. This is exactly the same as if I had just typed out true. And we can also do greater than or equal tos and less than or equal tos. So there are a couple basic comparison operators. Those are going to become pretty important once we get into if-else statements at the end of tonight. So there you go. We're actually comparing two numbers and then storing the result in a new variable. Some other cool stuff we can do with one operator I want to show you that works well with Booleans is the not operator. So this is the not operator. It's just an exclamation point. If we do that with a Boolean, it will just swap it. So it'll turn true to false and false to true. We can use that with a direct Boolean, or we could even use it with something that resolves to a Boolean. So x is not less than 3, so that becomes true. We'll talk more about those later. A couple more operators I want to show you real quick. These ones are a little weird, but they're pretty important when we get to looping tomorrow. So if you wanted to increase, let's actually change this to let. So with that example of age, we were increasing by 1. And it turns out that a lot of times we want to increase a value by 1. So there's something called the plus plus operator that increases a variable by 1. So this whole line of code actually says, take x and increase it by 1. So now x is equal to 8. This is a great opportunity to remind you of the difference between const and let. You cannot use plus plus with a constant variable because it's actually changing the value. So this has to be let. So what happens on line 4 is that in memory, the value of x is now changed to 8 instead of 7. And if we did it again, we would get up to 9. So that's plus plus. So when we were just doing, x plus 6, the value of x never changed. So this line of code will resolve to 13, though we can't see it because it's not our last line of code, but it never changed the value of x. Whereas plus plus does change the value of x. So there's the plus plus operator. There's also a minus minus operator. So that decreases things. So just a couple cool things you can do with numbers. All right, let's move on to properties and methods. This is another way that different data types in JavaScript are different. They have different things have these built-in things called properties and methods, and they're going to vary by type. So let's create, one second. So I've created a number x and a string that's stored in name. So it turns out that strings have a property called length. So these properties are built into the language, and they're going to be often type specific. So strings have length, and you look up the length by saying the name of the variable dot length. This is called dot notation, and it's used to look up properties. So this will tell us how many characters are in our string. If I threw some spaces in there, the length would go up. And if I even created an empty string, which is totally a thing, the length would be 0. So strings have length. If we tried looking up x.length, which is a number, we'd get undefined because numbers do not have lengths. So there are different properties that appear on different things. We'll go over a couple as we go through this, but length is kind of the one you need to know for right now. Very similar to properties are something called methods. So methods are very similar to properties, but they're a little more exciting because they are actually something called functions. And we'll talk a ton about functions next week. So there is a function called, for example, toUpperCase. So all strings have something called toUpperCase built into it. So toUpperCase is a way of transforming our string into an uppercase version of it. And so it is something called a method, and methods need to be executed. What that means, the simplest way to say that is that you need to throw parentheses on the end or else it will not run. So when you throw parentheses on, it says spit back out, resolve with an uppercase version of this string. So we never actually changed the value of name. We can tell because it's a constant variable. But we spit back out a uppercase version of it. So we could save this in something called name upper. And remember, this is exactly equivalent to this value of Charles uppercased. So if we wanted to, we could save it and use it later. Or if we're just playing around, we can run it as our last line of code and see the value it spits back out. So visually, functionally speaking, the biggest difference between a property and a method is that you need these parentheses in order to get methods to work. The more technical difference is that methods actually run code. So they run some logic behind the scenes and then give you a value, whereas a property just grabs a value from memory and gives it back to you. So this to uppercase is specific to strings. If we tried to do X to uppercase, we would get an error. To uppercase is not a function. With a method, that probably means that you just tried to use a method that doesn't exist, at least on that value. But there are other methods that exist on numbers, like toString, for example, which does what you might expect. It turns a number into a string. We could even run toString on a Boolean. And notice that I can put in the Boolean value directly if I want. And that gives me the string version of true instead of just the Boolean value of true. So there are a couple methods. Methods are part of a larger data type called functions. And once again, we'll talk a ton about functions on Monday of next week. So the thing you need to know about functions right now is that they need to be executed. That's the parentheses that I showed you on the end. They have something called a return value. So when we talk about what a function resolves to, we use this term return value. That's what is spit back out of a method, is the return value. So this returns the string version of whatever value you called it on. The other two terms I want to mention with respect to strings are parameters and arguments. That has to do with the input we put in on them. Before we really talk about those, though, I have to introduce you to some strings that actually have parameters. So let me put away those two terms for a minute, and I'll bring them back in just a second. So let's talk about global objects now. So all these variables that we've been using are built into the language. And in fact, if you try to list a variable name without ever declaring it, you will get, well, let's try first name. So we get reference error, first name is not defined. That's what happens when you try to use a variable name that you've never declared. So this is a common error to see at the beginning when you're just getting used to JavaScript. That means that you've used what might be a variable name without ever declaring a variable. The only exception is a global object. There are some default variables or default objects that are built into the language for you to use. Things like math or console. These are built into the language, so you can use them at your leisure. So what do? Well, they have some really awesome methods built into them. I'm going to start by talking about math and some of the math methods, and then we'll talk about console afterwards. So I'm going to do math.round. Math.round will round a number for you. So this is a function that requires inputs. To round a number, you need to put a number in the parentheses. So sometimes the parentheses are blank, but sometimes you actually have to put a value in. And then this will return out 1, which is the rounded version. So now I can define argument and parameter for you. So the argument is the thing you put in. So the actual value we put into this function call is 1.4. The parameter is what it expects in general. It expects one number. So math.round in the general sense expects a single number as a parameter. In this specific case, our argument was 1.4. If I ran it a second time with 1.9, we now have a new argument. In this case, the argument was 1.4. In this case, it was 1.9. In both cases, the parameter was still just one number. So we'll review those terms on Monday when we go, when we go into functions in a little more detail. Let me introduce you to a couple more math methods. So related to round, there is a method called floor. Floor rounds down every time. So think of the floor down. So even though we have 1.999, it rounds it down to 1. Related to math.floor is math.ceil. Seal as in ceiling, not seal as in sea mammal. So ceil rounds up every time. I don't know why they didn't just call it ceiling. It's another really common mistake is to try to type out math.ceiling and get error math.ceiling is not a function. So those are a couple useful little math methods. Another one that I am quite fond of is math.random. This does not take in any parameter. This just gives you a random number between 0 and 1. Different random number every time. And the last one is math.pow. It is not a comic book punch. It stands for power. So that's for exponents. If you wanted to do 2 to the power of 2, as in 2 times 2, actually let's do 3 to the power of 2. So that would be 3 times 3. It gives you 9. If you want to do 3 to the power of 3, which is 3 times 3 times 3, that will give you 27. So there are a couple math methods. So math itself is a global object. It is an object that is built in for you so you can run cool methods on it. And I've just showed you a couple of those that you might use. As a note, if you are curious about the syntax or any details on any of these math methods, a great place to check would be the documentation. I can't believe I've gone almost an hour without telling you guys to Google things. I feel ashamed of myself. And in fact, I have the string documentation pulled up here. So kind of rolling back a minute, here are all the things that you might do with your strings up here. So yeah, lots of string methods, don't need to know them. But you can look them up if you want. And I believe there is a stretch assignment that asks you to do just that. So another global object is the console. So the console is kind of weird, especially when you're just using Replit. Actually, let me open up. I said we were done with that code base example, but I'm going to show you it one more time. So if we go over and I just did Option Command J on my Mac, you could also do inspect element and switch over to the console tab. There is something called the console. It is built into every web browser. It is like your hidden JavaScript land. So if you are writing a website and you want to, let me open up that code base again. If you are writing JavaScript and you want to send a message to yourself, which is common for debugging, or a message to anyone who might look in your console, you can do that using a method called console.log. So within the JavaScript for this code base, I am writing console.log. I'm going to say, hello, Lambda friends. So the console has a built-in method called log, and whatever you put into log will appear on the console when this is run. So notice that message now appeared in the browser. So it's hard in this intro course to really conceptualize how important the console is, because it really comes into play when you're actually working with websites. Within Replit, you could still use it. So you type out console.log. You can type in a message, and it will appear in white. So here's a subtle distinction. Console.log does not have a return value. It resolves to undefined. We can see that in green. But the message appears in white. So when would we use console.log in this course? Let me show you. So let's say that we had a bunch of different values that we were assigning. And then maybe we do x++, x++, and then we define y, and then we look up y. Okay. So we can see what y is equal to over here in green, right? Because it's the last line of code. But what if we wanted to see x? We can only see one thing at a time in Replit unless we use the console. So if we wanted to, we could throw in a console log statement and actually pass x in. Remember, whatever x resolves to will be passed into this method. So now in white, we see the value of x, and in green, we'll see the value of y. And we could also console log y if we wanted to. We can console log as many things as we want. So console log is a great debugging tool for you guys. If your code is not working and you're curious what went wrong along the way, you can use a console log to see the results of it. And you can even add a little label in here. You can throw as many arguments as you want inside. So you could say x, comma, so it'll print out the string x, and then it'll print out the value of x. So now it's pretty clear, okay, that's the value of x. So there's console log, a really useful thing that I would recommend you use on the homework tonight when you get stuck. So that's a little bit about global objects and a couple methods that we can use with some of them. The last thing I want to talk to you about tonight is called control flow. So for starters, you can really just think about JavaScript as this line of code runs, and then this one, etc., until we're done. So it just goes down the list and reads the code. But that's not very sophisticated. When we're writing interesting apps and programs, we need something that's going to dynamically change based on outside conditions. So for example, let's say that we had some sort of app that told you what to wear. I've seen a few of these. It like recommends an outfit based on the weather. So a good starting point might be trying to figure out if it's raining or not. And just as a little insight into the real world, in this case, I have hard-coded in a Boolean value to raining, right? But in the real world, what we would want to do is we could actually query what's called an API. And an API is basically a tool we can use to get live data about different things. So we might query a weather API, and instead of just hard-coding in this value, we could have a program that updates in real time and finds out what the weather is in the exact location of our user. So we won't be doing anything like that in this intro course, but you will definitely be playing with APIs in Lambda School's main curriculum. And they are a really fun thing that you can do to make interesting apps. So just wanted to mention them. For now, we'll mock it out. We'll just hard code in raining to be true. So we want to tell our user to wear a raincoat, but only if it's raining. So if we said, for example, wear a raincoat, line 5 is going to run no matter what. It's not in any way dependent on this variable. So even if I set this to false, it says wear a raincoat. That's not what we want. This would be a case where we want what's called an if statement. Let me write it out, and then I'll break down the syntax for you. Okay, so this is saying only run line 6 if this is equal to true. So now notice our log statement never appears because raining is false. But if I change this to true and run it, now our log statement appears. So line 6 is optional. It's only going to run if certain conditions are met. So let me break down the syntax for the if statement, and then we'll talk more about it. We start with the keyword if. That says that we're starting out a conditional. Then we have a pair of parentheses, and inside that is the condition. So when this condition is true, the code will run. If it's false, it will not run. Following the conditional, the condition, we have a curly bracket, and then we put a closing bracket down on its own line. Notice that we don't need a semicolon here because the brackets already signify that we're closing something. So we need an opening and closing curly brackets. And then within here, we have all of our conditional code. So I could write a bunch of lines of code here. You know, I could say wear a raincoat, wear rain boots. It's maybe a little overkill. bring an umbrella. I could put as many lines of code as I wanted inside of here. And all of these will only run when the condition is true. Also notice that I've indented these lines of code. We talked about this a little bit with HTML, which is that when you have something like this, for example, when you have a block of code that's, in this case, we'll see more examples of this, but in this case, to signify that this is the code that's inside the if statement, this is the optional code, we want to signify that to ourselves and our fellow developers. So we always tab in whenever we have an if statement. And as I said with the HTML, this won't affect how the code is run. If we forget to tab it, or if we put everything on one giant line, the code would still run. It would just be a nightmare to read and edit. So practice good syntax, practice good white space habits at the beginning. And it's really hard to remember exactly how these things look. So when you're writing your own if statements, look up examples online. And while your logic might be different, copy where the parentheses go and copy how the tabbing is. And pay a lot of attention to that at the beginning. It will save you a lot down the line to practice good styled code at the beginning. So there is our first if statement. So what if we want a second option? So this is going to run if it's true, but if it's false, nothing happens. That's what an else is for. So we can follow our if statement with an else. On this line with the closing bracket, we just type out the word else, followed by another bracket, and then close it at the bottom. There's no condition necessary for an else. In fact, if you tried to put a condition in, you would get an error. That's because the else is the default option. So if will run if this is true, else will run if it's false. So we might say, wear a t-shirt. Not very sophisticated, since not raining does not necessarily mean t-shirt weather, but I think it's forgivable since this is your first exposure to conditionals. So now if raining is false, this else statement will run. If we change it to true, the if statement will run. So one or the other will run, never both, and always one of the two. Anything we type down here outside doesn't matter. Once we're done with the final curly brackets, the rules go back to normal. This line of code is not in any way affected by this conditional. So there you go. That is your first introduction to conditionals. We're going to be digging super deep into those tomorrow. So that is everything I have for you guys tonight. I know tonight's lecture is a little bit of a doozy and I threw a lot at you. You'll have a lot of opportunity to practice this on the homework and make sure you do ample amounts of Googling. Code examples are your friend when you're starting a brand new language, especially JavaScript. So let me go over the homework. I see there are a bunch of questions floating in the Q&A. I will get to those in a minute, but let's talk about the homework for a second first. The first assignment is all about code reading. So there are a bunch of different exercises. There's a little bit of instructions here, but mostly you're going to be working over here. So what you can do is, for example, in exercise 1, you'll look at each of these and you have to say what variable types are variable 1 through 5. So I introduced you to some of those types. You have to go in and figure out what is this and what is that and what does this line of code resolve to, et cetera, et cetera. So yeah, and then you just type them in over here in the comments. And then this one asks for the values. So this is like, you're going to answer things like Boolean, string, number. Down here, actually tell us what they resolve to, so the actual value of them. And then so forth. So there are a bunch of questions down here. When it says let answer 3, you actually set this equal to. So how many variables are declared? If you think it's 6, set that equal to 6. What 2 values were logged? Actually set it equal to the values that were logged. And then at the end, what you can do is you can actually click down and say run tests, and it will tell you which ones you got right. There aren't tests for all of them, unfortunately, but it's a good way to test at least some of the values. Another little tip on this is that it might benefit you to open a separate replet window. It's super easy. Just say new, go in, say new replets or my repls, and there's a new replet option. So it might benefit you to go over here so that you can, if you're confused about something, you could always say copy over a chunk of this code and run it over here. And maybe you could check what values are equal to. Just a little hint of something that might help. Be warned, if you copy over only part, you might end up with variable 2 is not defined. So make sure you copy all the relevant code over. So that is my big tip for especially tonight's homework and maybe all the homework moving forward is you can copy chunks of it over to a new replet to play around with it. So this is the code reading section. In this one, you are going to be doing more code writing. So for example, you need to create a number here. So you might replace this with the number 9. So don't edit this up here, but just change the value of replace me to different things. A little hint on this one, you'll be doing different things with pi. Try using this value of pi we defined for you. That might help. You could also just type out pi every time you want. There's a little if-else statement. This one's tricky. You have to create a randomizer. And then down here, you'll be assigning variables. So notice this says, is x less than y? We can see that x is not less than y. I don't want you to type in false. I want you to actually say x less than y. So you'll be using these values of x and y here. So there's a couple little examples of what you might be doing. So kind of went through some of these. I will say the homework for tonight is super tricky. I'm just going to say that up front. I think this might be the hardest homework. That's kind of, I mean, it's going to depend person to person, but the homework tonight is super tricky. We're trying to drill this in with you. So be patient with yourself. Do lots of Googling. Play around in your own REPL window. Be patient with yourself. Once you have this groundwork laid, it's going to get a lot more fun. I promise. Just bear with me. So that's the homework for tonight. And as far as submitting it, there's actually a submit button. So from here on out, the homework will be in Replit and you can actually submit it. But run the test first. So that is the homework for tonight. I see a bunch of questions. I'm going to answer as many as I can, but we're also getting a little crunched on time, so I might not get to all of them. I apologize. All right. I see a comment that I want to address, which is Michelle said, I feel like all I do is Google. I spend 90% of my time Googling. Good. That's how it should be. That's how it is on the job. You spend 90% of your time Googling. So that is a sign that you are doing it right. There's a question about who can we reach out to for help regarding the lecture. So just post your questions in the Slack channel for this class and a TA will get to it, or maybe another student will help you with it. If you're totally lost and no one's helping you out and you're banging your head against the wall, you can always direct message me. I encourage you to ask the group first so I don't get too bogged down with those. I can't always get to them right away, but I do try to address all of them. So that's kind of a last resort, is you can always ask me directly on Slack. We have a question about white space. So JavaScript does not care about white space. Most languages do not care about white space. Python is actually an exception to that, but do not underestimate the importance of putting in white space. It is the difference between nightmare code and code you can actually work with. Another comment that I want to address is about the speed of this lecture. I know this one is rough. I introduced you to a ton of stuff. I will say that a lot of what we talked about tonight, we're going to see a second time in different lectures. So you will have a chance to go over a lot of this stuff a second time throughout tomorrow and all throughout next week. So yes, I'm aware it is a very fast-paced lecture tonight. So be kind to yourself when you're doing the homework tonight. Let's see. Okay, here is a question about combining things. So this was something I did kind of near in the middle of the lecture, is I did something weird like this. So if you combine a string and a number, the result is a string. That's just one of those things. There's lots of little quirks in JavaScript like that. And if you're coming from an object-oriented language, you're like probably going, what? What is this abomination? But yes, JavaScript is kind of a flexible language. So you can do wacky things like combine strings and numbers, and JavaScript will be like, ooh, we think you meant a string, so here's a string. If you combine a number and a number, the result will be a number. And if you want to check for yourself, notice that we can tell in Replit that that's a number because there are no quotes. We can tell that this is the result of this is a string because it does put the quotes in Replit. So that's a good way to tell if you're working with a string or not in Replit. All right, let's see what else we have. How and when will we receive access to the homework? I believe that they will, I believe that they will post about that in, Slack after the lecture. So you'll be able to access it via your Replit. The details on that, I'm sorry, they keep changing the way they're doing this. Stay tuned in Slack and we will let you know about the homework. We have a question about float values. There are no float values in JavaScript. This is a question that's going to be relevant if you're coming from probably an object-oriented language. So if you don't know what I'm talking about with floats, don't worry about it. So there are no floats or doubles or anything like that. There's just numbers. All numbers are numbers. All right. A few people have asked about the difference between let and var. Oh, I see a question about let versus var and let versus const. So I'll answer both of those. Let versus var. Okay, my answer for let versus var is going to be a little hand wavy. I'll tell you about it tomorrow. I know that's kind of a disappointing answer, but there is something called scope, and let does something kind of cool when it comes to scope. Var doesn't. I will introduce that to you tomorrow, and I will mention how these are different tomorrow. So short answer is that let does something a little more sophisticated that var doesn't. I will tell you what that is tomorrow. Let versus const, I definitely want to talk about because that's something you should know tonight. So the difference between let versus const is that you can reassign a let variable. So if you have a placeholder for a index like 0 and you want to increment it, that's allowed. I was just incremented up to 1. If this were a constant variable, we can't increment, we can't reassign it, we can't do anything. Once I has been declared, it is equal to this value and it will never be equal to anything else. All right, a question about homework history. You should have access to the homework you already did within your CodePen. If you've saved it, you can go into your CodePen and look up my pens and see it. You'll be able to, similar thing will happen in Replit. You'll have access to all your old homework via Replit. So yes, you will have access to your homework history. All right, I'm going to wrap up the questions for tonight because I want you guys to have as much time as possible on the homework. All right, so that is it for tonight. Once again, I know tonight's lecture is a doozy. We give you a lot of content all at once. So do lots of Googling on the homework tonight. Be patient. As I said, a lot of this other stuff will be covered, will be reviewed as we go through other topics. So I kind of just like threw everything out on the floor for you guys, and then we'll be digging into each of them in more detail as we go through. All right. So that's it for tonight, and I will see you guys tomorrow for more conditionals. Have fun with the homework.